Good morning, second period. Mr. Dewitt reaching from beyond. I'm currently in Florida. Well, actually, not while I'm recording this, but while you're listening to it. And I'm just going to talk to you a little bit about compounds and elements and the difference between them. Now, you should have already read this activity that is up on the screen here. So it's the activity 5. Let me get to it here. And this is what it should look like. Activity 5, element meets element. And I've already given you a copy of this, and you've read about the difference between the different types of compounds. So an element is a pure substance that we see on the periodic table of elements. So carbon by itself, oxygen by itself, nitrogen, fluorine, sodium, the different atoms we've been looking at. Those are elements. But sometimes elements join with other elements to make compounds, and that's what happens a lot in nature. So as you've read, a substance produced from the combination of two or more elements is called a compound. There are different types of compounds that we're going to study. Namely, we're looking at organic compounds and inorganic compounds. So an organic compound contains the elements carbon and hydrogen in them. Carbon and hydrogen together. Remember, that would be a C and an H. All the rest of the compounds that do not have carbon and hydrogen in them are considered inorganic, not organic. Okay, they were not once part of a living thing, and they would not have carbon and hydrogen together in them. Let's look at some examples. You read glucose. So when you guys were in 7th grade science and learning about photosynthesis and cellular respiration, you learned a little bit about glucose. That's just sugar. Any type of sugar has the base of glucose in it. And glucose is C6H12O6. Notice it's got carbon, that's the C, and hydrogen. That means it's organic. Now, compounds like carbon dioxide, it's got carbon, but no H, no hydrogen. So that's inorganic. Limestone, like if you've ever been to Luray Caverns, limestone has carbon, but no hydrogen. So it's not organic. That means it's inorganic. Even water. We all drink water, we have water in our bodies, but it's not organic because it doesn't have carbon and hydrogen together. You go to McDonald's and get some salty French fries, they've got this in it, sodium chloride, NaCl, table salt. No hydrogen or carbon, that's chlorine, so not organic. But then the gas we put in our car, octane, look at that. That is organic. That's why we call them fossil fuels. They came from living things. So the directions is you're going to go flip to the other side of this page, and we're going to fill in something together here. On the other side of your page, we have a chart that looks like this, and it should say elements and compounds. So these are going to be examples of some things that could be elements or they could be compounds, and we're going to kind of tease out all the different parts here. So first thing we're going to look at is anthracite, which is the scientific name for coal like you would burn. It's got a chemical formula of, look at the element symbols, carbon, hydrogen, oxygen, nitrogen. So it's got 4 different elements in it. It also is telling us, look at these numbers here, are telling us how many of each element. I've got 70 carbons, I've got 11 hydrogens, I've got 8 oxygens. Nitrogen, there's no number there, and that means there's just one of them. They just don't bother writing it. Okay, so the first box you guys have to fill out is it an element or a compound? Well, remember the definition of a compound from the other side of the page is that it's any substance that has 2 or more elements. Well, we got 1, 2, 3, 4, so that means it's a compound. Okay, now I already did the element symbols here for you, so I wrote out each of the different element symbols: carbon, hydrogen, oxygen, and nitrogen. What we need to do now is count up how many for each one. Well, this isn't too hard. We go back to the formula, just like we were looking at a moment ago. There are 70 carbons, so I'm going to write down 70. For hydrogen, H, there are 11. For O, there are 8. That's oxygen. And for N, remember, if there's no number, we just need to assume it's 1. So there's 1 nitrogen. The next question asks, how many total atoms? Well, we're going to do a little bit of math. We're going to add all these numbers together. So I've got 70 plus 11 plus 8 plus 1. And you could plug that into a calculator, but 70 plus 11 is 81. 81 plus 8 is 89. 89 plus 1 is 90. And you can trust the Do It calculator here. Next is the compound organic or inorganic? Well, we went through our reading earlier and we noticed that organic compounds have to have carbon and hydrogen. And this one has both carbon and hydrogen, so that automatically means it's organic. I'm just going to put an O here. Almost looks like a box. I apologize. We're going to keep this blank. You can even scratch it out. We're not going to worry about this right now, mostly because we haven't talked about ionic or covalent. We'll come back to that another time. Let's do another example. So look here. We've got ozone. That's like what's in the atmosphere. O3. It's asking, is it an element or compound? Remember the definition for compound? 2 or more elements. I've only got oxygen, only 1 here. So the answer to this is it's an element. If you only see one type of element symbol, that's just going to be classified as an element. Next is, what is the element symbol? Well, this is easy. There's just one. It's oxygen. There's an O. How many atoms for each element? Well, there's only oxygen, and it tells me right here that there's 3 of them. 1, 2, 3. So this is easy as well. How many total atoms? Well, there's only 3. Lastly is the compound organic or inorganic? Remember, in order to be organic, you have to have carbon and hydrogen. Ozone has neither, so the answer is it's inorganic. Let's skip down and look at oil shale. That's this one. Al2, Si, O, C, and H. The tricky part with this one is we've got a lot of letters and we need to figure out. Remember when we were talking about elements, we said if there's a lowercase letter, that means it goes with the uppercase letter. So this isn't A and I, it's actually Al for aluminum. That's one element. And then we have capital S lowercase I, so that's silicon. That's one element. Then we have O by itself. It's capital. That's for oxygen. Then we have C. Then we have H. So this one has a whole bunch of different elements. 1, 2, 3, 4, 5. So obviously it meets the 2 or more rule, so it is a compound. Let's list out the symbols. This ought to be fun with my little computer mouse here. We've got Al. We've got Si. We've got O. We've got C for carbon, and H for hydrogen. Not too bad. Now we've got to add in the numbers. You would write Al equals, and then we would look here. There's 2 Als. And then we'd say Si equals, there's no number in between Si and O. So remember, if there's no number, we assume it's 1. So there's just one Si, one silicon. O is 5, so O equals 5. Carbon is 20, so C equals 20. I'm running out of room here, so I'm just going to write down here H equals 40. All right. Next task is the total atoms. So remember, I add them all up. 40 plus 20 is 60, 65, 66, 67, 68. So I have a total of 68 atoms. I can just imagine somebody screaming out 21 right now. Lastly, is it organic or inorganic? Well, look here. I've got aluminum, silicon, oxygen, carbon, and hydrogen. So since I have carbon and hydrogen, the answer is yes, it is organic. All right, your job now is to finish the rest of this chart. You can fill it in, and then I'll have an answer key for you to check yourself against. So go ahead and fill in the rest of this chart. It was nice talking to you from the beyond.